Alright, so we're going to review Chapter 8. Let's start with number 1. I'm going to, as much as I feel it, like I want to get on your case and make you feel bad about not being able to do these, it just pains me when I grade these things, especially on 1 and 2. Look, it says find the geometric mean. So if I start yelling at everybody, Jen, you stop me, okay? So find the geometric mean between these numbers. So number 1 is 2 and 8. Now watch very carefully. Write this down, okay? You should be writing this down. Even if you got it right, at least it gives you something to do, all right? So it says find the geometric mean. So when we find the geometric mean, we set up a proportion. I think most of you understood that. I don't think that was a problem. Now, I remember one in particular. I don't even know who it was, but because I graded a lot of these. But somebody didn't even put an equal sign in between. Okay, that equal sign is pretty important. So make sure you put an equal sign. These two bars are fraction bars, right? We have two fractions. It's a proportion. And so what does the geometric mean? Well, it's that one and what else? Top left and bottom right. Okay, that's the geometric mean. That's what we're solving for. So that's the first thing you have to do. So there's no way that you should not know how to start this thing. When it says find the geometric mean, you put two fractions equal to each other. You put an x on the top of this side. You put an x on the bottom of the other side. Everybody clear on that? It's just a matter of practicing this stuff. All right, I'm starting to feel that urge to start yelling, so I'm not going to. So here we go. It's 2 and 8. And then you put the other two numbers here and here. It doesn't matter what order. The 8 could have gone here. The 2 could have gone here. It doesn't make any difference. All right, but you put a 2 here and an 8 here. Everybody okay with this? Now, I remember somebody doing this. I don't know if it was the same person. I have no idea. I just remember seeing this, and I thought, well, that's kind of funny because I've never done that in class. Some people did this, or some people. At least one person did this. They said, oh, 2 goes into 8. Cancel out the 2 once, cancel out the 8 4 times. You can't do that. You can only do that if these two things are being multiplied times each other. Are they being multiplied times each other? No, they're not. Okay? You can't cancel out a 2 here and a 2 here. If there's an equal sign in between, and I know what you're thinking. I know you're thinking of that rule about multiplication and stuff cancels out. That's not the rule here. This is not being multiplied. Okay? So watch what you do. You cross multiply. So x times x is what? X squared. You got to put the squared there. And then you multiply these two together. Do you see why it doesn't matter whether the 8 is here or the 2 is here? Because I'm going to go 8 times 2, 2 times 8. Doesn't make any difference. So I'm just going to write this out. 2 times 8. Now some of you guys made this way more difficult than it should have been. I made these numbers really easy so they come out real nice and pretty. So watch. X squared is equal to, let's multiply these together. What's 2 times 8? It's 16. Is your answer 16? No, it's not. Okay, what do you have to do to get rid of that square? Take the square root. That'll go away. All right? I mean, technically, you're square rooting this, right? So the square root and the square go away. But I'm not going to put the square root there. But if I took the square to this side, I have to take the square root of this side. Now, some of you guys left it the square root of 16. I gave you credit for it. Probably shouldn't, okay, but I did. You should know what the square root of 16 is without even using a calculator. But if you really, really needed to, let's use the calculator. Square root of 16. So I hit square root and I hit 16. Here's another situation. I talked to Mrs. Bove. You know, she's been helping some of you guys and some people from the other class. And again, I don't even know who this was. She didn't tell me. But she said that some people were using a different calculator. They were used to this calculator, but they were using another calculator. But don't I almost every single time when I show you how to do something on this calculator, explain to you how to do it on the TI-30? How many times have I done that? Dozens of times. Would you agree? That I say, okay, this is how you do it on this calculator, but if you have the TI-30, this is how you do it on the TI-30. Well, you have to listen to both of those because you never know. You never know if your battery will die on this. You have to borrow a friend's calculator and they don't have this calculator. You need to know how to do it both ways. That's part of the reason anyway why I say it both ways. So on this calculator you hit square root, then you hit 16. If you had a TI-30, what would you hit? You wouldn't hit square root first. What would you hit? 16. You hit the number first, right? You hit 16 first, then you hit the square root. Everybody okay with that? Now you hit equals, and there it is. It's a 4. But you should be able to do that in your head, right? Square root of 16, you should know that. So that is how you should write your answer right there. If I was real tough and real particular about this kind of thing, and there are teachers out there that are really, really picky on how you write your answers. If you would have written the square root of 16, some teachers would have marked this wrong. Okay, I gave it to you because you showed me the right way to do this, and that's what I was testing on. But some teachers will make you write this as a 4, and if you don't, you're going to get it wrong. All right, so you need to be aware of that. All right, number 2. It's very similar to this. It's 9 and 36. So it's the geometric mean, again, between 9 and 36. Let's go through this a little bit faster. So the x goes here, and the x goes here, the 9 here, and the 36 right here. Cross multiply, so it's x squared equals 9 times 36. Let me show you 2 ways to do this, okay? I'll show you the way that I probably would have done this if I was doing the problem, okay? And I did the problems. I made up the answer key, so I did every single one of these problems myself. So watch, you take the square root, that goes away. Take the square root of this. This is a nice, easy way you can do this without a calculator. This is the square root of 9, which is 3. This is the square root of 36, which is 6. What's 3 times 6? It's 18. That's your answer. To me, that's the easiest way to do that problem. You could have done this, though. You could have taken 9 times 36 and put that into your calculator. 9 times 36. And you get that big number right there, 324. If you walked up to me on the street and said, Mr. Hamrick, what's the square root of 324? I probably couldn't tell you. All right? That's why I like doing it this way, because I could do this without a calculator. But if I take the square root, watch, take the square root of 324, which is my answer, and then I hit equals, look what it happens to be. It's 18. So just putting this into a calculator, you get a simplified answer, don't you? All right? I didn't even ask you, though, did I, on these problems to write it in simplest form? Did I? I just said solve for x. So if you would have kept this the square root of 324, I would have given you credit for that. I think I even gave, somebody wrote it like this, and I just left it like that. And I still gave you credit, but I think after, by the side of it, I put simplify. Can't remember who did it, but I remember like a bunch of these problems, that person wrote it like this. Okay, what I'm testing on is to see if you know how to set it up as a geometric mean and cross multiply and all that kind of stuff. But again, you're going to encounter some teachers that will not accept that as an answer. They will only accept this right here, 18, as an answer. So you need to be aware of that kind of stuff. All right? But I accepted this, and of course I accepted that. All right? That was pretty nice of me, wasn't it? Yeah, I didn't have to do that, but I did. All right, enough of that. Now, how do we use that geometric mean? So we know how to find the geometric mean. What's the use in finding the geometric mean? Well, that's what this next problem is all about. So let's draw this problem out. I've got a big right triangle, about like that, and let's make this a little bit different. Let's make it like that. There we go. That's not perfect, but it's close enough. Let's say that that's a right angle right there. And then we drop a perpendicular down from this right there. Okay, so that's our situation. So I've got x here, I've got y here, and I've got z right there. And this is 3 and 9. So these are 3 problems. This is number 3, 4, and 5. So number 3 said to solve for x, which is this one. Number 4 said to solve for y. Number 5 said to solve for z. So we just have to solve for x, y, and z. Well, let's do x first. X is a geometric mean. I've gone through this many, many times. If you didn't know how to do this, I'm just convinced that you didn't study for it, okay, or you didn't look at the YouTube videos. There's no way in the world, if you looked at these YouTube videos at this stuff and you watched me do these problems, there is no way in the world that you didn't even know how to start this thing. There's just no way. All right? I'm just convinced that you just didn't try. You didn't put out the effort. Here, I'll go again. Stop. Okay, so you gotta watch now. Okay, let's watch now. X is a geometric mean. We already talked about what a geometric mean is. right? It's two fractions set equal to each other. If x is the geometric mean, it goes here and here. The only thing that you have to remember, okay, in order to do this, is between which two numbers. Up here, they told you straight up which two numbers, didn't they? All right, so there was no doubt which two numbers that geometric mean was between. But on this one, you have to figure out what are those two numbers, and they're kind of right here. First of all, let's find that whole entire length right there. What is that whole entire length if this is 3 and this is 9? It's 12. So this is what you have to remember, okay? There are times when you have to memorize stuff, all right? That's just the deal. All right, Christian? Head up, please. Head up. Everybody's head up. Everybody's head up. Revan, head up. Sit up straight. Back up against the back of the seat. There you go. If the back's against your seat, then your head won't be on the table. Okay. So watch. X is a geometric mean between what and what? That's what you have to know. Between the whole thing, which is 12, and the segment that's closest to the x, which is which number? 3. You have to know that. All right? I mean, it's as basic as I could possibly make it. All right? I could have switched it up, and I could have given you this and asked you to solve for this down here. That would have been a little more complicated. I made it as straightforward and basic as I possibly could make it. So we cross multiply. We've done this a couple times already. This is 12 times 3. When we cross multiply, x squared. Look, 12 times 3 is what? It's 36. I know what the square root of 36 is. It's just 6. That's your answer. It's not 5 point anything. Doesn't round to 6. It's exactly 6. I had some people put 5.9, marked it wrong. It's not 5.9. It's exactly 6. Let's do y. Y is also a geometric mean. It's a geometric mean between two numbers as well. This time, y is my geometric mean. But you got to know what two numbers is between. Well, it's very, very close to what x is. It's between the whole thing, which is 12, and the side that's closest to y. Which one of these segments? Which one of these two segments is closest to y? 9 is, right? So it's between the whole thing, 12, and 9. That's all you have to remember. It's really not that much to remember. You have got to practice it. Okay, you have got to learn it. Sit there, watch the YouTube videos, and get it in your head and practice it. Do it 2 or 3 or 4 times. You're going to get this stuff down. It's not difficult at all. I'm convinced you just didn't study it. I'm convinced of that if you didn't know how to do this. Yes?
How do you get the ones like this where it doesn't give you both measures?
We're not even going to do that. Okay, I mean, it gets a little more difficult, but this is as basic as it gets. But you're right, I could jazz these up a little bit, make it a little bit tougher, and I could, no, maybe on the quiz there was, but not on the test, okay? I made, again, like I said, I made it as basic as I possibly could. Right now, we're just going to stick with the test right now, okay? If sometime later you want to, I'll show you how to do it. We can do that. So let's cross multiply. So it's y squared equals, and then just 12 times 9. Now look, you could simplify this. I'm not even going to bother doing that because I don't think some of you guys really care that much. So I'm going to take the square root. 12 times 9 is 108. So if you wanted to just keep it 108, that's perfectly fine. If you wanted to, or square root of 108, if you wanted to put that into a calculator, the square root of 108, you could have done that too, 10.4. So I accepted all kinds of ways on this. You could have simplified this. This is 3, that's a 2, that would be 6 square root of 3. So 6 squared of 3 is also another option. It's probably the most difficult way to write it as far as trying to figure it out, but you could have just multiplied the numbers, stick it under square root, and you would have been done with it. You didn't even have to put it into a calculator to find that. I would have accepted that answer right there. Alright, let's do z, and we'll be done this geometric mean stuff. So let's find z. Z is a geometric mean as well. So that means it goes here and it goes here. Now, between which two numbers? This is actually the easiest of all 3 of them. Yeah, it's just between these two segments, 3 and 9. So you just put a 3 here and a 9 here, cross multiply. Z squared equals 3 times 9. You could write it a couple different ways. This is actually easy to find you could take the square root. So you could write it just the square root of 27, right? 9 times 3 is 27. You could have written it like that. That would have been fine. Or you could have simplified it. What's the square root of 9? 3. So you could have written it 3 squared of 3. Or you could have put it into a calculator and got a decimal for it. That would have been okay too. I gave you 3 different options on how to write that answer. That's probably the easiest right there of all the options. Everybody with me? Kenny, you following all this?
Yeah.
Get your head up. Put your back up against the back of the seat. Do it, please. Kenny. Thank you. All right, let's take a look at 6, 7, and 8. 6, 7, and 8 are almost all the same type of problems. It says, determine, and I started off being real picky about this, because it says justify your answer, right? So I was going through it first, when I first started grading, I was going through and saying, well, if they don't show me exactly why they got the correct answer, I'm going to mark it wrong. I was being Mr. Tough Guy. But then too many people were missing them. I'm like, I'm not going through this. If they put obtuse and it's obtuse, I'll give it to them. So that's what I did. I'm being way too easy on you guys, way too soft. I should be a lot tougher, all right? But I'm just letting you know that you should be able to justify your answer. Now watch. They give you these two numbers. First of all, we have to determine if it's a triangle to begin with. So what's the rule for determining if it's a triangle? We take the two smaller ones and add them up. So if I add those up, I get 50. And what do? 50 has to be bigger than what? 40. Is 50 bigger than 40? Yes, it is. Now that doesn't tell me if it's an acute triangle. It doesn't tell me if it's right. It doesn't tell me if it's obtuse. The only thing that does is tell me if it's a triangle to begin with. So is it a triangle? Yes, it is. So you could write yes. Because what does the question say? It says determine whether each set of numbers can be the measures of the sides of a triangle. So can these be a triangle? Yes, they can. So technically, that should be part of your answer. If you didn't put that, I didn't mark it wrong. Some people did, though. That was good. So yes should be the first part of the answer. The second part of the answer, if it is a triangle, tell me which kind of triangle it should be. And that's what a lot of you guys are getting mixed up on. Remember, this is how we do it. Let me show you. We take c squared. If c squared is equal to a squared plus b squared, what kind of a triangle is it if that's true? If c squared equals, what kind? It's a right triangle. This is a right triangle. Look, it's Pythagorean Theorem, right? So if it's equal, then it's a right triangle. If I took c squared and it was greater, it was larger than a squared plus b squared, what kind of a triangle is it? It's obtuse. How do we know that it's obtuse? Several people came to me and said, Mr. Hamrick, I put the stuff in right, I just couldn't remember which one was which. How can you remember that greater than is obtuse? Because an obtuse angle is what? Greater than 90 degrees, right? So when I think of greater than, I think of obtuse. What's the other one? C squared would be what? Less than a squared plus b squared. If c squared is less than a squared plus b squared, what kind of a triangle is it? It's an acute triangle. Right? Why can you remember that? It's easy. Because an acute angle is less than 90 degrees. Any of this sinking in?
Yes.
All right? I'm giving you huge hints. I'm giving you great ways to remember which one of these it should be. And that should pop in your head. You shouldn't say, oh, I just forgot which one was which. It's not a matter of just memorizing. It's a matter of thinking what the words mean. Obtuse means greater than 90 degrees. You should have known that long, long time ago, correct? Acute means less than 90 degrees. So obtuse goes with greater, acute goes with less. I thought that was pretty self-explanatory. And we've talked about that, and I gave you those hints before. You have to take what I say, remember it, internalize it, study it, and you'll do great on these tests. But the ones that aren't doing great are not putting the time and effort into it. I'm convinced of that. So let's do this. Still got 10 minutes. So what is the C, what is the A, and the B? Well, look, I'll give you a huge hint. Every one of these problems I give you on a quiz or a test, the first two are the A and the B, and the third one is the C. All right? It's the way in the book. They do that in the book. I do that on the quiz. I do that on the test. All right? So we take the C and we square it. So we take 40, we square it. I like to put a question mark here because I'm not sure right now whether they're equal, less than, or greater than. So I put question mark. Then I take the other two, 20, and I square it. And I take 30, and I square it. Notice where I put the C. Look where the C is. It's on the left-hand side, isn't it? Some of you guys are going a squared plus b squared on the left-hand side and putting c squared on the right. Don't do it that way because that'll mix up your obtuse and your less than and your acute, and all that kind of stuff. Obtuse greater than, acute less than. Do it the way that I'm showing you. So what do? Plug some numbers in. Oh, I can do these numbers. What's 40 squared? That's 1600. How do I know how to do that in my head so quick? Is it because I'm super smart? No, I'm not super smart. I'm actually kind of dumb. All right? But watch. 4 times 4 is 16, right? You got a 0 here, and you square that, you get a couple zeros, right? So that's how you square it. That's not hard. What's this? Now, watching how I did this, what's this thing squared without a calculator? It's 4 and then a couple zeros. What's this? 9 and a couple zeros. Add these up. What do you get? 1300, right? 9 and 4 is 13. So compare 1600 to 1300. What is 1600? It's what? It's greater than 1300. What kind of a triangle is this if this is greater than this? It's obtuse. Okay? You're not going to be able to take it in here because I'm going over the same test that you're taking. Okay? So,
do you want me to
go to the library because they're having lunch in the multi-purpose room. So, okay? They're still up there. All right, does that make sense? Look, what did I do right here? I justified my answer, didn't I? All right, that's the justification. That's what I was looking for right here. All right, and then that's your final answer to tell me what kind of a triangle that is. Make sense? All right. With that said, let's do 7 and 8 much faster. Getting into a rut using that same color. Let's use a different color. Here's the 3 numbers, 6, 12, and 20. Let's determine if it's a triangle first of all. That's what we did for the first one, isn't it? 6 and 12 is what? 18. 18 has to be what? Greater than 20, bigger than 20. Is it? No. So is this even a triangle? No. So we say it's not a triangle. Boom. You don't have to have an exclamation point, but there it is. And then you're done. If it's not a triangle, it can't be obtuse, it can't be right, it can't be acute. So we just say it's not a triangle, we go to the next one. That was number 7. Let's go to number 8. Let's go green. Now look, some of you guys looked at this and you flipped out because it looks real crazy because there's square roots. But for some of you, you looked at this and you remember what it's like to square a square root, right? Now, I can't add these in my head real quick. If you wanted to add them, this will be bigger than this. You can do that on your own. Okay, so it is a triangle. You can do that if you want to. Stick them in a calculator. How do we determine if it's acute, obtuse, or right? Well, we take the C. Remember, this is the A, this is the B, this is the C. Take the C and we square it. Look. Yeah, exactly. This is even easier than squaring a 40 or a 20 or a 30, isn't it? If I square a square root, what does that become? Just plain old 13. See how easy that is? And some of you guys looked at this stuff, oh no, square roots, and I saw all kinds of crazy work for these things. This is so much easier, right? And then we watch. We take the square root of 5, we square it, and then we take the square root of 12 and we square it. Why are we squaring them? Because it's c squared compared to a squared plus b squared, correct? So that's what we do. What's the square root? I'm sorry, what's the square root of 5 squared? It's just a 5. What's the square root of 12 squared? It's just a 12. All right, question mark. That's 13. What about this? What's 5 and 12? 17. Compare it. What's 13 to 17? Is it equal? Is it greater than? Is it less than? Come on, talk to me. It's less than. I got one person awake in here, right? Come on, you guys. I know it's a little warm. I get it. All right? But, you know, you guys should be hungry to figure out how to get these answers right. Okay? According to the grades on those tests that I gave you. All right? So you guys should be looking at this and saying, oh, that's how you do it. Oh, okay, I see it. But I'm not seeing any of that. I'm just saying, oh, going to sleep, put my head on the desk. All right? That's ridiculous. I don't even know why I'm doing this. I'm starting to yell, aren't I? You're supposed to stop me. So this is what kind of a triangle? It's an acute triangle. Sometimes I think I care more about your grades on this test than you do. Is that true? It shouldn't be. It should be the other way around. You should care way more than what I care. Okay? It seems like I care a whole lot more than what you guys are caring. I show a lot more enthusiasm and a lot more gumption. Is that a word? I don't know. Sound like an old man. Gumption. Where'd that come from? All right. Let's do 2 more, and we'll do half of them, and then we'll be done, right? And we'll do the other half tomorrow. So, all right, here we go. Wow, these problems right here. I don't know what some of you guys are thinking. I've said this so many times. If you have a right triangle and they tell you two sides of a right triangle, look up on YouTube. Count how many times I've said this. If you have a right triangle and you know two sides of a right triangle, what do we use to find the third side? We use Pythagorean Theorem. Exactly right. You don't use law of sines. You don't use law of cosines. You don't use trig functions. You use Pythagorean Theorem. If I have a right triangle and I know two sides, I use Pythagorean Theorem every single time to solve for the third side. I made this one as easy as I could. You got a calculator? No, you don't know any. You don't know an angle. Use law of cosines? Yeah, but why would you go through that? You can, but why? Why would you? Okay? That's like saying, well, I could go out and drive a car that's already built, but I think I'll go out back, take all the scrap metal I can get, and put it all together, then I'll drive that around. What would you rather do? Drive something that's already put together, right? Same thing here. Use what's easiest. Use Pythagorean Theorem. All right, so it's x squared equals. Now remember, it's c squared equals a squared plus b squared. C is the what? It's the hypotenuse. On the next problem, that was a problem, okay? Because a lot of you guys didn't do it correctly. On this one, most people got this one okay. So x squared is equal to 16 squared plus 33 squared. You're like, oh, I don't know what those numbers are. Well, I don't either. So you stick them in a calculator, right? So you go 16 squared plus 33 squared equals that big number right there, 1345. So x squared, it's supposed to be squared, x squared is equal to 1345. Is that my answer, 1345? No, I got to solve for x. We've done this like 3 times today. How do I get rid of that? Square root both sides. You could have just kept it like that if you wanted to. I accepted that. If you wrote it like that, I'm perfectly fine with that. Or some people put it into a calculator, and I would be fine with that as well. 36.7, okay? So 36.7. Now here's something that really fires me up, okay? Not that I'm not fired up already. Read the instructions to me. Somebody, Scrappy, read it to me. It says find x, and what does it say after that? To the nearest what? Somebody else say that. Round to the nearest what? 10th. How many decimal places is the nearest 10th? 1 decimal place. Look, I got people that did this. They showed this, and then you know what they wrote as their answer? 37, and they circled it. Oh my goodness. I just don't understand why. It just goes beyond me to understand why you would do this. What does the instructions say to do? Round to what? Nearest 10th. Which one is the nearest 10th? 36.7, right? That's the nearest 10th. I'm telling you, there's teachers out there, and I should be one of them. I'm convinced of it, but I'm not. I'm too soft-hearted for this, okay? I'm not tough enough. Some teachers would mark off if you did this. Because in the instructions, what did I say? I said round it to the nearest 10th. Is this rounded to the nearest 10th? No. Look, there's your number right there. That is not 37. That is 36 point what? 7. The 7 rounds a 6 up to a 7. Right? This should be marked wrong. Shame on you if you put 37. I mean, I saw people see 36.7. I saw it right there on their paper. And then they put equals 37 and they circled 37. Read the instructions, okay? Round to the nearest 10th. Getting a little fired up, aren't I? That's okay. Somebody needs to get fired up because you guys aren't fired up near as much as you should be. It should really be bothering you, and I don't think for some of you guys it really bothers you enough. Maybe you're just not showing it. Maybe that's what it is. But I'm showing it. Look at this. C squared equals A squared plus B squared. Which one is our C here? It's the 28. So many of you put 11 squared plus 28 squared equals x squared. Okay, raise your hand if you did that. Show me. There's more than that. I bet you. Yeah, there we go. Okay, see? I got a witness. All right, look. You don't go 11 squared. Just because they're the two numbers, you don't just put those and set it equal to x squared. This is the A, this is the B, this is the C. So you have to go x squared plus 11 squared equals 28 squared. With me? And now you got to do some math. It's not that hard. Get rid of the 11 squared. I'm not even going to punch numbers in the calculator just yet. I'm going to move it over first. If I move it over, it's going to be minus 11 squared, isn't it?
Yeah.
All right, because that's a plus 11 squared. We put it over here. It's minus. Now I can use my calculator and plug the stuff in. So 28 squared, minus 11 squared equals 663. Now watch. If you would have put this, it's supposed to be squared. Okay, watch. Square root both sides. So you get the square root of 663. If you would have kept it like that, that would have been, well, it really wouldn't have been okay. Why not? Why would that not be okay technically? Because what does the problem say to do? Round it to what? To nearest tenth. And earlier I said that would be okay, but technically that really wouldn't be okay, would it? Because it says to round it to the nearest tenth. I still gave it to you. Oh, shouldn't. I'm mad at myself for not being tougher. Okay, watch. So it's the square root of 663, and then it's 25. What does that round to? 0.7. That 4 does not round that 7 up. Don't look at the 8 and say, oh, the 8 rounds the 4 to a 5, and then the 5 rounds the 7 to an 8. No, you could be doing that all day long. You only look one place after the place where you're rounding it. So it's 0.7. So it's 25.7. That should be the only acceptable answer right there. All right, we've done half of it. We did half the test. And I think I was pretty good about not yelling too much. I got a little bit worked up there at the end. All right, but you got to see my, you got to see why, don't you?
If we get these signed, we get 2 extra points, right?
Yeah, you get 2 extra points if you get it signed. Okay, tomorrow we're going to do 11 to 20, and that's going to be our review. Come in awake tomorrow. Let's stay awake tomorrow. Bring your test. Don't leave them home. Bring them tomorrow, and we're going to go over 11 to 20 tomorrow.